Welcome to the fifth lecture on the first module of ocean structures and materials. I hope you have been following the remaining 4 lectures which we discussed in the yesterday's class. Let us quickly look at the presentation outline of this specific lecture. We discuss in this lecture different compliant type offshore structures. Under this basis of compliant type of offshore structures, we will talk about drill ships, and further we will also give you some basic outline on concepts of drilling, because if you have got a design or plan for any offshore structural system for the process of exploration of oil and gas, one must understand certain basic terminologies and basic activities related to drilling. So, this lecture will also focus on basics of drilling. Let us talk about the first part of the lecture, explaining drill ships. What are drill ships? Drill ships essentially are ships which are specifically designed to carry out drilling operation. The name is derived directly from drill ships. So, they are nothing but ships meant for drilling operations. These are nothing but specially designed boats which house drilling platforms which can carry drilling at deep sea locations. A typical drill ship will have a drilling platform and a derrick located on the middle of its deck. In addition, drill ships also contain a hole which we call as a moon pool. Moon pool is nothing but a hole which extends right through the ship down through the hull. This allows the drill string to extend through the boat down into water. Drill ships are actually used in very deep waters which can be quite often turbulent. In that cases, to keep them in positioning, we use what is called dynamic positioning system because of the turbulence effect in deep waters. What is a dynamic positioning system? Dynamic positioning system is a complex algorithm which is equipped with electric motors on the underside of the ship's hull. It is capable of propelling the ship in any desired direction you want. The dynamic positioning system comprises of propeller motors which are integrated with the computer system of the ship. Now, the computer system which is integrated with the propeller motors use satellite positioning technology in conjunction with the sensors located on the drilling template. The very objective of bringing the alignment of the drilling template with that of the propeller motors of the ship hull is to ensure that the ship is always positioned directly above the drill site at all the time during drilling operation. It is an adaptation of standard seagoing ship of a mono hull form. Drill ships are nothing but standard ships of mono hull type. There are some additions to this standard ship. Additions are actually the substructures which contain a moon pool, cantilevers from which the drilling operation can be carried out. Now, drill ships are nothing but large vessels which are equipped with additional means of positioning the unit over the drill center. You may wonder why I have got to position the drill ship exactly over the drill hole. It is required to establish a close contact with the borehole in the seabed. Drill ships are nothing but large vessels which are held in position either by a mooring system or by a dynamic positioning system as explained in the previous slide. You may wonder why drill ships require a special mooring system while performing drilling operation. Drill ships are highly susceptible to wave action. Criticality in the response is extremely important because the vessel is connected to the seabed by a riser and the drill string is in contact with the bottom of the borehole. Now there exists a strong coupling between the motion of the vessel with that of the motion of the riser under environmental or lateral loads caused by waves and current. Therefore, the response of the ship with the coupled motion of the riser dynamics becomes critically important. Drill ships are designed to carry drilling operations at greater distances offshore and in very deep waters. A drilling platform and a derrick will be located in the middle of the large open area of the ship. You may recollect the terminology, which is a middle large open area in the ship, which I call as a moon pool. Moon pool is nothing but a hole extended through the hull, through which the drilling risers will be placed through the hull to the drilling template. Drill ships have similar to the appearance of a ships, except that drill ships drill while floating on sea surface. During operation, the drilling takes place through a hole which we call as a moon pool. The large derrick is mounted permanently above the moon pool, which is similar to that of a land rig. Drill ships can drill holes up to 3000 meter deep and are typically used for exploration drilling. Remember, drill ships are never equipped or never adapted for production drilling. Now you may wonder, different kinds of offshore platforms have different specific applications in exploration. Some are used for production, some are used for production and storage. While they have been designed, some of them having a fixed base, some of them have a floating nature, some of them have a hybrid combination, which is for example like a TLP. Now drill ships have great advantage of drilling in greater depths, but essentially only for exploration activities in remote locations. Drill ships are very highly mobile, therefore this can be considered as one of the important advantage of drill ship in offshore application. Essentially, drill ships can travel anywhere as they are self propelled, similar to that of a ship. They are also relatively unstable and liable to be tossed by waves and currents. Therefore, you must be very careful in employing them in rough sea states. While the ship is in motion, when the drilling is not carried out, the ship has a high degree of stability, but when the ship in position, when the drilling is carried out, they can become unstable and they can be liable to be tossed by the wave and currents. Many drill ships are equipped generally with what we call dynamic positioning system. We can recollect what is a dynamic positioning system, referred as DPS in the literature. Dynamic positioning system use computers to detect whether the ship has strayed too far from its desired location or the ship is located exactly above the drill hole. Whenever it is necessary, these dynamic positioning systems, which are computer control algorithms, activate the thrusters which are located at the bottom hull of the ship, and the ship will be moved to the desired location in place. So dynamic positioning system help to establish a continuous contact between the drill ship thrusters with that of the template on the drilling base. So it ensures that the drill ship is located physically vertically exactly above the drill hole which is to be drilled. Here is a conceptual picture of a drill ship which you see here. As I said, it is a conventional form of a large vessel like a ship shaped vessel. The vessel contains derrick which are used or which are necessary for doing drilling. I put them as a drilling platform. The vessel also has moon pools which are nothing but holes created through the hull through which the drilling risers will run. Of course, it has got azimuth propulsion which are used for maneuvering the ship while motion, but not while drilling. Of course, these units what you see here are the standard components, the residential quarters, the housing blocks, the turbine generators, etc., which are standard equipments of a conventional ship. As you see here, the ship is also housed with what we call dynamic thrusters, which is nothing but computer controlled dynamic positioning system, which enables the ship to turn in any direction as desired, so that the ship always stays exactly vertically above the drill hole to ensure more efficient drilling. The maximum number of crew and scientists who can be placed on board in a typical drill ship cannot exceed 120. That is a limitation here. Of course, drill ships can be recollected to understand that they are used only for exploratory drilling and not for production drilling. This is again a schematic overview of a drill ship when it is afloat. Drill ships are also having problems associated with rough sea states in case of ice breaking, etc. This is another typical figure which shows how the drilling operation is carried out in a drill ship. You can see here the red line shows me the seabed. These are the drilling risers. This is where my hydrocarbon flow is being happening to show through the drilling bit. This is my helipad, which is enabling an helicopter launching on the drill ship. These are my living quarters and mechanical and electrical equipments used for maneuvering the ship. The red one what you see here is the derrick, which houses all necessary plants and equipments that are required for drilling. The dynamic positioning system which are housed at the under hull of this will enable the drill ship to be positioned exactly vertically above the drill hole where the drilling has to take place. Photographs shown here are few examples of drill ships which are in operation. For example, you see on the left side the drill ship what you see here is named as ultra deep water drill ship. The name derives the specific depth of water at which this drill ship can be deployed. You can see the mechanical systems are highly complex in nature. The top side is as complex and as facilitative as that of any fixed offshore type platform as well. You can see the complexity involved in the derrick here. This is the derrick. There must have been a moon pool exactly below the derrick. The drilling has to take place in this direction. You can see the living quarters here. You can see the cranes which are used for facilitating the equipments or placement of equipments on board. You can see an helipad here which facilitates landing of helicopters in case of any emergency. The other example photograph what you see here is a Discoverer India drill ship which is being used at a depth of 2.95 kilometers. Again you can identify the components here. This is a drilling derrick. There must have been a moon pool below here where the drilling will take place. I can see an helipad here, can see a crane here, can see a complex mechanical system on the top. The third photograph what you see here is a very famous Sagar Valley drill ship which is used by ONGC in India. These are some of the photographs which will show you the details of moon pool. You can see here moon pool is nothing but a hole which is driven on the top of the hull which passes through and through. You can see there is a hole through and through. You can see the water bed here, you can see the sea surface here. Okay. This is a very specific drilling mechanism, or the drilling risers are connected in pieces as the drilling progresses deeper and deeper. So drill ships essentially are preferred for deep water drilling. The application of drill ships can be very helpful in remote areas where the weather environment is moderate. Remember very carefully, drill ships cannot be used in critical sea states. In critical sea states, drilling operation cannot happen because drill ships are highly susceptible to tossing by the wave and the current action. High mobility and large load carrying capacity are considered to be salient advantages of drill ships. As you see, drill ships are very large in size and the load carrying capacity is substantially high, and as a ship it has got high degree of mobility and maneuverability. In comparison to semi-submersible, let us try to compare how drill ships stand in comparison to semi-submersibles. In comparison semi-submersibles, drill ships are advantageous because the conventional ship shaped hull enables easy maneuvering or easy movement or easy mobility in compared to semi-submersibles. Drill ships can be subjected to longer periods of downtime under wave and wind action. What do you understand by downtime? Downtime is the time of operation where the drill ship will remain in sea while drilling takes place, whereas in semi-submersibles the downtime where the drilling operation can take place is highly limited and lesser in comparison to that of drill ships. Drill ships essentially can be used for smoother waters because I do not want a rough turbulent weather, though you may wonder in turbulent weather dynamic positioning system will enable the drill ships to keep or stay in position, but performing a drilling operation in a rough critical sea state will always cause stability problems to the ship as such. Therefore, drill ships cannot be used in rough sea states. So, it is recommended that drill ships can be used in moderate sea states. So, semi-submersibles however can drill in most hostile environments as well. So, there are some merits of drill ships in comparison to semi-submersibles. There are some advantages of semi-submersibles in compared to that of drill ships in terms of its working weather environment. In most common case, the platform is generally equipped with anchor lines. A mooring system generally of this order has about 8 to 12 anchor lines for each platform. However, in water depths deeper than 1000 meters, a mooring system becomes uneconomical or impracticable. Now, one may wonder, what do we do if we want to go for drilling beyond 1000 meters? Obviously, the alternate solution is dynamic positioning system. What is a dynamic positioning system? DPS basically is a control which activates the control system of the platform, which controls essentially the displacements in 3 horizontal degrees of freedom, namely surge, sway and yaw, because these are the degrees of freedom where the responses of a drill ship can be large during drilling operation. So, dynamic positioning system develops a control algorithm even to limit these responses as well under the wave action. DPS is composed of a controller, a sensor system, a thruster system and a power system. Put together is what we call dynamic positioning system. The sensor system actually feeds to the controller with the information about the platform positioning and the environmental parameters. The sensors keep on reading the estimates of wind, current and wave loads exerted on the ship or on the drill ship, as well as the geographic and geometric positioning of the ship with respect to the GPS locations. So, these two data will be integrated, will be compared and will be fed and feed forward by the sensor system to the computer controller. Once the controller receives this information, it compares the GPS position of the drill ship with that of the actual position of the drill hole. The controller commands the action of thrusters indirectly so that the ship can be brought back to the original required destination. The thrusters are generally installed at the bottom of the platform hull. These thrusters actually generate forces and moment required to counteract the environmental forces. You may wonder how the ship recognizes the environmental forces acting on the hull. Basically, the sensor system which is fixed will recognize the forces imposed by the wind, waves and current, and they will be activating the thrusters in an opposite direction to counteract the environmental forces acting on the ship. Therefore, this reversal forces will now keep the platform at the reference point or at the desired location. Now, the controller keeps the platform within a tolerance of radius about 2 to 6% of the water depth. So, as you go deeper and deeper, the tolerance level with which the DPS will enable positioning of the drill ship on the drill hole will be about 6 to 10%. So, as you go deeper and deeper, the accuracy of positioning the ship exactly over the drill hole will be weaker and weaker. These are some of the photographs which I wanted to show you as far as the drill ship is concerned. Of course, you have seen the real drill ship in operation. So, this is a typical drill ship. What I want you to appreciate is see the length and the dimensions of a ship compared to any standard offshore platform. So, they are very large in size and they have no problem in floating. They are very stable when at least they are not doing drilling operation. You got a very high drilling rig mast fixed on the top hull. There has got to be series of moon pools through which I am going to do drilling, and these are all different cranes which have been used for lifting and placing the mechanical equipments. I will also have different other arrangements on the hull as we saw in some of the examples. What you can understand here is a drill ship may be a conventional ship which is converted for drilling operation. The additions are a drilling mast, tools and equipments which are required for drilling in deep sea. The plan and elevation view of a drill ship, naval architects can easily understand and appreciate the necessity of this plan. You can see this is basically the plan of a ship which is conventional, but I am here making alterations to put a derrick over this. So, essential alteration is a very big moon pool at the center and one more moon pool on the side. So, I can do two parallel drilling operations in this case. So, only through the hole drilling is possible as far as drilling ships are concerned. You got an engine deck here, you got laboratory located here, you got all other topside deck facilities like sauna, pool, gym, etc. to facilitate people working on board. This picture shows a global information about different kinds of platforms located worldwide. Worldwide, if you look at the simple statistics, there are about 392 jackup platforms, 163 semi-submersibles and about 38 to 40 drill ships. If you look at the Southeast Asia segment, we maximum use 31 jackups, 11 semi-submersibles and 7 ships. If you look in particular India uses predominantly jackup rigs and very less number of semi-submersibles and ships. If you look at the Middle East, people use only one kind of drilling rigs, which is nothing but the jackup rigs. If you look at the West African coast, people use jackup rigs substantially high and semi-submersible ships also equivalently higher. If you look at Brazil, people use lot of semi-submersibles and drill ships in comparison to jackup rigs. If you look at Mexico, people use predominantly jackup rigs as that of Middle East. If you look at Gulf of Mexico, which is hub city or hub location for exploration and oil production, they use majority of jackup rigs, semi-submersibles substantially high, drill ships lesser and submersibles further lesser. If you look at the North Sea, people use jackups on the whole very high. So, this gives a very interesting information for you that jackups are predominantly commonly used and deployed around the world by many agencies in many countries. Next to that, followed by which is the semi-submersibles, followed by which are the drill ships. So, one may wonder why the statistics does not show what are the platforms installed in these locations. If you look at my previous lectures, I given interesting statistics about the number of fixed platforms, compliant platforms, articulated towers, gravity based structures, etc. installed around the world, especially predominantly in Gulf of Mexico and in United States and other countries as well. Now, ladies and gentlemen, we have come to an end of this lecture in sense that we have discussed different kinds of offshore platforms used for drilling. As I told you in the beginning of this lecture, to design, understand, develop, plan and guidelines of designing of offshore structures, one must understand certain basic concepts of oil drilling platforms as well. Let us look into some basic concepts of oil drilling. Start from a petroleum product. Petroleum product comes actually in a barrel of crude oil, which is a composition of 19.5 gallons of gasoline, 9.2 gallons of fuel oil, 4.1 gallons of jet fuel, about 2.3 gallons of asphalt, about 0.2 gallons of kerosene, and about 0.5 gallons of lubricants, and about 6.2 gallons of other products. So, it comes in a barrel which approximately weighs 42 gallons. If you look at petroleum and natural gas deposits are actually found in sedimentary rock basins, where tiny sea plants and animals died millions of years ago. In the presence of proper temperature and pressure, these plants and animals eventually turn into what we call hydrocarbon reserves. Oil and gas are made mostly of hydrogen and carbon, that is why they are called hydrocarbon reserves. These hydrocarbons flowed into empty spaces in the surrounding rocks. These empty spaces are called traps. Finally, an oil soaked rock which is similar to a wet sponge is formed. These traps are unfortunately covered with a layer of solid rocks or a seal of salt or clay. This confines the oil and gas from escaping to the surface. So, the oil and gas which are formed naturally by the death of animals and decay of plants which are trapped in the surrounding areas and empty spaces, they get confined by solid rocks over and above them. So, our purpose of drilling is just to drill through these rocks to reach these traps. So, drilling is done through these formations to explore oil and gas from these traps. There is some important terminology called exclusive economic zone, which we call EEZ. This picture shows you how the EEZ is defined. For example, you have got a land, from the land about 200 miles beyond into the ocean, we have got definition for exclusive economic zone, which can be used for offshore drilling. For example, till 3 miles from the shore we call this as territorial region, and then up to about 20 to 25 miles we call them as continental shelf, and beyond that we call them as continental slope, and the specification of the EEZ lies about 200 miles away from the offshore. If you look at United States EEZ standards or statistics, for example, USA EEZ extends by about 3 billion acres underwater. If you look at the land area, it is only 2.3 billion acres. What does it mean is that the economic exclusive zone of United States, which is about 3.9 billion acres underwater, which is larger than the land area, is going to serve as about 30% reserve of the US gas and oil reservoirs in the offshore basins. So, that is a great advantage what US basins have. If you look at the steps and efforts made toward oil and gas exploration, oil and gas exploration is actually time and effort intensive process. It relies on collection and detailed analysis of extensive geologic information. You may wonder what are those geologic information required to proceed before oil and gas exploration is done. Surveying and mapping of the surface is done, and the surface is also done to show the geological features. You can say what are the techniques used for doing surveying and mapping on surface and subsurface geologic features. Techniques such as seismic reflection is one of the predominantly used technique to identify the hydrocarbon traps. The potential of geologic formation is estimated to compute economical producible oil and gas from the trap. The best locations are then identified to carry out exploratory drilling to test these traps. Exploration and delineation wells are drilled to determine the area and thickness of the oil and gas reserve on the exploratory wells which are identified from the survey. Now, one may wonder what do we understand by delineation wells. Delineation wells are wells drilled outward from the successful wildcat well to determine what is the possible extent of oil formation. Actually, delineation wells essentially are used to find the boundaries of the productive formation. Now one may wonder now what is a wildcat well. The wildcat well is nothing but an exploratory oil well drilled in land which is not known to be an oil field. For example, I do not know whether a specific location where I am drilling will yield me oil. So if I do that, I do exploratory oil well drilling, I call that kind of well as an wildcat well. Logging and coring wells or other type of wells which are drilled to measure the permeability, porosity and other properties of these formations. Once a specific location is identified as potential space which contains oil and gas deposit, then one or more number of exploratory drills are drilled. To provide information on the composition of the underground rock layers and the geological and geophysical properties, surveys are carried out. We do what we call well logging. Well logging actually refers to performing tests during and after the drilling process. It is done to allow the geologist and drill operators to monitor the progress of well drilling, how deep we are drilling, how wider we are drilling and how far towards the boundary we are drilling. If you want to know them, we have got to do what is called well logging. To gain a clear picture of surface formation, well logging is very highly useful. Well logging is also useful to identify specific rock layers, in particular those that represent target zones for further exploration. If you look at the process of oil and gas welding drilling together, today almost all oil and gas wells are drilled using what we call rotary drilling. There are different kinds of drilling operation. Rotary drilling is a very common method by which drilling is done throughout the world. In rotary drilling, a length of a steel pipe, what we call as a drill pipe, with the drill bit at its end is rotated. As the drill bit is rotated, it keeps on cutting hole which we call as a well bore. As the well goes deeper and deeper, additional sections of the drill pipe are kept on added to the top of the rotating drill string. The rotary drilling uses a steel tower to support the drill pipe. This is what we call as a drilling mast. If the tower is a part of the tractor trailer jacked up, we call that as a mast. If it is constructed on site, we call that as a derrick. So there is a difference between the drilling mast and a derrick. If it is tractor trailer and jacked up as we keep on proceeding drilling, we call them as a drilling mast. If it is constructed on site as a total, it is called as a derrick. Towers constructed of structural steel are mounted on the derrick floor. This is where most of the drilling activity occurs. Four major systems comprise an operational rotary drilling rig. Let us see what are they: power supply system, the hoisting system, the rotating system and the circulating system are four vital complements of what we call as a rotary drilling. So this is an anatomy of an oil ring. You have see this is a derrick, which is nothing but a mast. This is where I am going to draw a moon pool and this is where I am going to do drilling. This is my drilling casing which you see in black color here. This is my drilling string. The end of the drilling string is what I call as a drilling collar. The drilling collar will terminate with a end piece or a mouth piece which I call as a drill bit, which will look like a rotary drill bit like this. For doing drilling, enabling drilling, you need lot of electric power. So in an electric generator which supplies power for this kind of drilling. So to prevent any accident while drilling happening, we fix what we call as a blowout preventer on the top. As we all understand, drilling needs lot of rotational forces. I must have a facility to move and align the drilling rig as I require. So I need what is called as a turntable on the top. Of course I need turbo engines which are powered by electric generator to perform drilling operation. Here is a photograph and a schematic view of a drilling rig. This photograph shows the drilling rig in position. This you have to see is a drilling mast. Of course the drilling mast top is what we call as a crown block. the crown block is connected to the drilling bit, and the crown block is what is going connected to the drilling pipe or the drilling casing. The outside of the drilling pipe is what we call as the drilling casing, or the hole is what we call drilling casing. Draw works will keep on supplying the necessary liquid or any injected pressure to perform drilling. Of course, you need mud hose, Kelly to control the drilling operation. As I said, you also need what we call as a turntable or a rotary table. Mud pump is required to keep on circulating the mud while drilling is in operation. What is the major difference between an onshore drilling and an offshore drilling? The major difference between these two is that the nature of drilling platform itself. In addition, in offshore drilling, the drill pipe must pass through the water column before entering the sea floor, whereas in onshore drilling there is no problem of a water column at all. So, the drilling casing or the drilling pipes will be subjected to lot of lateral forces exerted by wave, wind and current action, whereas in onshore drilling no such problems are encountered by the drill pipes. Offshore wells are generally drilled in water as deep as about 3 kilometers. What is called as a drilling template? It is a very common terminology being used in offshore drilling. Let us talk about drilling template. Offshore drilling actually requires construction of an artificial drilling platform, the form of which depends on the characteristics of the well to be drilled. Offshore drilling also involves the use of a drilling template that helps to connect the underwater drilling site to the drilling platform located at the water surface. So, drilling template is nothing but the layout of the form of drilling area which we are going to do, which will be connecting the drilling site to that of the drilling platform which is located on the top hull of a drill ship. This template typically consists of an open steel box with multiple holes depending on the number of wells to be drilled. So, it is nothing but a layout of a frame, steel frame which is having different kinds of holes. All these holes indicate probable location of the holes to be drilled in deep sea. So, now the drilling template will establish a connectivity between that of the holes to be drilled with that of the drilling procedure to be carried out from the hull. The template is installed on the sea floor of the water body by first excavating a shallow hole and then cementing the template into the hole. The template provides a stable guide for accurate drilling while allowing movement of the overhead platform during wave and wind action. What we understand by directional drilling? Ladies and gentlemen, as you see here in this figure, if you want to do a drilling actually from the moon pool of a ship, I said the moon pool should locate exactly above the drilling hole, and I prefer to do drilling vertically down. But sometimes you have to also extend the drilling not exactly vertical but also in the all possible lateral direction to touch as far as possible the boundary of the hydrocarbon traps. So, when you do drilling which is not purely vertical, I call this mathematically as directional drilling. Directional drilling is not a new technique, it has been deployed in offshore industry since late 70s. Normally wells are drilled vertically, however in many occasions we may have to drill the well at specific angles other than 90 degrees. Directional wells are drilled straight to predetermined levels and then gradually curved. So, the angle of inclination of turning of these wells are gradual. Now, by changing the direction of the drill bit in small increments of not more than certainly 2 to 3 degrees at a time, it is possible to drill many wells into the reservoir from a single offshore platform. That is one of the great advantage you have in case of directional drilling. Directional wells may also be deflected from the shoreline to reach a reservoir under nearby water. Directional wells are very useful in avoiding fault lines which can cause hole problems severely during drilling operation. They can also be used in instances where it is undesirable to set a rig exactly on a given spot exactly above the hole. You can locate the rig at a different location, whereas the drill hole is not located exactly vertically below the drilling location. If you have any such situations because of environmental reasons, then one can do what we call directional drilling. What do we understand by well completion? Once the well has been drilled and tested, that is logged, core and pressure data obtained, now a decision must be taken whether to complete the well or to plug it. So, what do we understand by well completion? The target reservoir rock porosity and permeability will indicate what is the possible potential flow of oil and gas present in the well. If it does not justify the cost to complete the well, then it is plugged with concrete in several places and the well is what we call abandoned. Suppose if you find after doing exploratory drilling based on the logged core well and pressure data, you decide that the well does not have enough potential of oil and gas reserve, then the well can be completely abandoned by plugging it with concrete in several locations. If the test formation indicates that the well is commercially productive, then the well should be completed. So, what do you understand by completion then? In such cases, production casing is run down the hole and then cemented. Once the casing is in place, a tool called perforating gun is lowered into the well bore to blast holes through the casing, cement and into the reservoir. These holes are made to establish communication between the reservoir and the production casing. Tubing is then lowered into the casing. A plug is set above the perforation as a barrier between the production casing and the tubing. This allows the natural pressure of earth to push hydrocarbons towards the well bore and to the surface through the tubing, unless a pump jack is required sometimes in some cases to raise the fluid to the surface. This photograph shows you the importance of a secondary recovery in terms of the wells. Of 60% remaining in the reservoir, can always do the recovery by different methods of enhancing the yield of the well. Can do water injection, can do gas injection, can do steam, can do chemical or can do even fire injection. Actually these are all pumped into the reservoir to force additional petroleum out of the pores in the reservoir rock. What you see here may be a production well or an injection well. The black ones what you see here are all producing wells, whereas the blue ones what you see here are all injection wells. Injection wells are actually used to enhance the oil recovery from the wells. I hope you have understood some basics of drilling from this lecture. Thank you.